Alright, so in this video, I'm going to solve the equation x to the power of y is equal to y to the power of x. So I want to find both of the values of x and y. And there could be multiple solutions to this. So to solve this, I'm going to first let I'm going to let y equal to k times x. K being a constant, so k can be any number. So this means that, going back from here, I have x to the power of kx, I'm substituting kx for y, is equal to kx to the power of x. Now I'm going to take the square root on both sides, so I get x to the power of kx to the power of 1/2 is equal to kx to the power of x to the power of 1/2. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So now I get x to the power of kx over 2 is equal to kx to the power of x over 2. Now, I'm going to take the power of 2 over x on both sides. So these two cancel out, and these two cancel out, and I'm left with x to the power of k is equal to k times x. Now I'm going to divide both sides by x. So these two cancel out, and I get x to the power of k over x is equal to k. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So this turns into x to the power of k minus 1 is equal to k. And now if I take the power of 1 over k minus 1 on both sides, these two cancel out, and I get x is equal to k to the power of 1 over k minus 1. So this is the value of x. So now remember how y is equal to k times x. So this means that y is equal to k to the power of k over k minus 1, because x is k to the power of 1 over k minus 1, so this times k would just be k to the power of k over k minus 1. Now, remember, k is just a constant, so I'm just going to let k equal to the number 3. So if this is true, then this means that y is equal to 3 to the power of 3 over 3 minus 1, which is 3 to the power of 3 over 2, which is the square root of 3 to the power of 3. And if this is the value of y, then going back, x to the power of y is equal to y to the power of x. So the square root of 3 to the power of 3, the square root of 3 to the power of the square root of 3 to the power of 3 is equal to the square root of 3 to the power of 3 to the power of x, which is equal to 3 to the power of 1 over 2, which is the square root of 3. So we can check if this is true by using the property a to the power of m to the power of n is equal to a to the power of m times n, meaning these two multiply, so I get the square root of 3 to the power of the square root of 3 times 3 is equal to the square root of 3 to the power of 3 times square root of 3. So these two are equal to each other, meaning our value of x in relationship to y is true. Now, if you haven't already, please make sure to subscribe, leave a like, and share this. Thank you. Alright, so in this video, I'm going to solve a challenging exponential equation. So the equation is x to the power of x is equal to 2 to the power of 2048. So to solve this, I'm going to first start by writing this as 2 to the power of 2 times 1024. Where I rewrote 2 to the power of 2048 as this. So x to the power of x is equal to 2 times 1024. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So I can rewrite this as x to the power of x is equal to 2 to the power of 2 to the power of 1024, which is equal to 4 to the power of 1024. Now I can rewrite 4 to the power of 1024 as 4 to the power of 512 times 2. And I'm going to use the same property. So this turns into 4 to the power of 2 to the power of 512. And 4 to the power of 2 is 16, so this is 16 to the power of 512. Now, I'm going to do it for one last time. 512 is the same thing as 256 times 2. And I'm going to write this as 16 to the power of 2 to the power of 256. And 16 to the power of 2 is 256. So I get 256 to the power of 256 is equal to x to the power of x. And because both the base and the exponent are the same, this is right. So this is my answer.